So in this video, we are going to look at the example I gave in the previous video, just taking an investment and seeing how it evolves when it comes to an annuity. And we're going to see if we can come up with a type of pattern. And then using that, we're going to basically introduce this idea of the recurrence relation. So our annuities, we can think of these as recurrence relations. I'll talk more about what that means in a little bit, but we're just going to revisit this kind of idea we were talking about before. And we said that we had an investment, and at the end of every year, we contribute $1,000 to it. So we basically started with $0. So we can think of our value, that's what this V means, value at 0 years to be $0, right? We said that this had an interest rate of 10%, and we're going to contribute $1,000 at the end of every year. So we can think of V0 as being 0. When the first year happens, your amount, your future value, instead of FV, let's call this V1. So we're going to say that this is the value at the end of 1 year. So the value at the end of 1 year, we have our value at the start. So value at 0 years multiplied by our rate, 1 plus our rate, so from our future value formula, and then we added the 1,000 at the end. Once we had this amount, our V1, at the start of your next year, at the end of your next year, your value at the end of the second year, let's call it V2, equals to this thing over here. Now, 1,000, if I just highlight it here, this guy here is V1. In the same way that 0 here was V0. Okay, let's look at the next one. At the end of the third year, our value at 3 years, at the end of 3 years, we'll call it V3, equals our value at the end of the second year, multiplied by this and then adding 1,000. So we're kind of noticing a pattern, right? Every previous year's amount becomes the initial amount. Then we apply the interest to it, and then we add our next deposit. So we kind of notice a pattern happening here. So we see that to find the value on the next year, we take the previous year's, multiply it by 1 plus the rate to the power of 1, or just 1 plus the rate. Then we add our deposit, we add our payment made. That's what our amount over here is. So if we wanted to kind of formalize this, looking at this pattern, we notice that if I want to, let's take comparing V3 to V2. To find the value at the end of the third year, I'm going to call this V3, but I'm going to write it as V of n plus 1. I'll explain why I'm calling this that in a moment. Now, the n here is from the previous year. V of n is the value from the previous year. That's this guy over here. So to find the value at the end of the next year, that number of years 2 plus 1 gives you your 3. So that's why I'm writing V n plus 1 equals your value from the previous year multiplied by 1 plus the rate. Now, I can write to the power of 1, but anything to the power of 1 just gives us that amount back. And then we plus our amount that we have added onto it. We're doing that every single time. And here we have something that models this progression of our investment. We're taking our previous year's amount, the value from that year, multiplying it by 1 plus the rate, that's your interest, then adding your extra amount that you've put in. Remember, what makes an annuity is that we're adding an extra bit at the end. So we essentially have here our, what we call recurrence relation. Now, this is the recurrence relation for an investment. Because remember, there were two cases. When it was an investment, we were adding this. When it was a loan, we were subtracting this. But that same pattern goes for the loan as well. If you remember back to the previous video, it followed the exact same thing where we inputted in our value from the previous year, applied the interest, and then we took away an amount of money because we're paying this off. So we're trying to reduce the value of the loan. This guy over here is for the loan. We add for an investment, we take away for a loan. Now, a recurrence relation, to formally define it, it uses the previous result, so the result, the value from the previous year, to generate the next value in recurring calculations. So it's like a pattern, right? We're doing the same thing over and over again. It's recurring, and it's recurring by this rule. Now, the Vn plus 1, as I said, that's the value of the investment or loan after n plus 1 payments. That's the kind of constantly the new amount we get at the end of every year, given in this example. V of n means the value of the investment or loan after n payments. The R is the rate of interest per compounding period. We typically express these as a decimal. You'll see these when we go into our examples in the next video. And D is the payment made per compounding period. Now, for an annuity, we may decide to make a payment at the end of every month. We may decide to make it every week or once a year or even once a day, right? But that's not as feasible. But this amount, what makes it an annuity is we have this extra payment per compounding period that gets added if we have an investment and gets taken away if we have a loan. But this video is just here to help you understand, by looking at the pattern that we established in the previous video, how we can make a general formula, a general recurrence relation to explain our annuities. So in the next video, we're going to do some practice questions to do with our annuities as recurrence relations. But that brings us to the end of the video today. Thank you so much for watching, and I'll see you next time.